Hello everybody, you're welcome into this, the fourth video in the series on setting up a template on an ET200 Siemens PLC for use and for adaptation to suit world skills automation tasks, particularly up to regional finals levels, and which can be used again as a basis or a springboard to develop for your national final solutions. So in the last video, I believe it's been some time now between the last one and this one, so apologies for that delay. But in the last one, I believe we had finished up with coding outputs into two separate categories. One that was safety dependent outputs there that we didn't want to operate when we had safety provisions dominating, and other ones where we wanted to maintain their operation, maintain their accessibility. So in this video, what I want to do is I want to focus on the sequence, just putting in a very basic sequence that can be developed and can be molded, shaped, tuned for whatever the regional final task C dictates. So to do that, what I'm going to do is I'm going to add in a new block. And this block is indeed going to be a function as the rest of them are. It is going to be coded in a CL, and the name of this I'm going to call SEQ underscore one, sequence one. Okay, so it's going to populate itself into the program blocks, and there we go. Right, so we're interfaced here. I'm just going to double check what I have in my data. I have a sequence 1, a sequence 2, and a sequence 3 in here. If you recall in the last video or a video before that, when we brought in sequence 1 into the my data block, we associated that with the UDT that we created in the very first video, and in that UDT we had space allowed for timers and counters, and in the earlier videos what we did was we had populated our preset time for each timer to be 2 seconds, right? So there was 2 seconds, 2 seconds, and so on, right? And then for our counter as well, the values we presetted on it was in function. All our preset values there for our counting function, our IEC counter, was set to 2. So that's the same for counter 1 all the way down to counter 8. Function PV is 2. So all of them have been preset, right, in the my data block. So this adds to what we're going to look at specifically in the sequence, or any sequence function, not even sequence 1, but likely we'll have a sequence 2 and sequence 3, but they're all going to be operating the same way. So let's do sequence 1 and see how we go. So inputs and outputs, again, as always, nothing. The only place you have something, the inputs and the outputs, is in your CP interface. But certainly in the in out, what I'm going to have is sequence data. Right? So I'm going to call it sequence data. You can call it sequence 1 if you want, but we're coding sequence 1. So sequence data, I'm going to map it to sequence 1. Data type is going to be UDT sequence. Right? I'm also going to want to put in here my management block, because I want to write out to management when the sequence is complete. Maybe I want to tell management what the step I'm in is, and so on. Management, UDT management. And put in my inputs, because my inputs are going to be digital inputs here, are going to be the catalysts by which I'm going to proceed from step to step, or maybe turn certain timers on or counters to increment. And of course DQ, I don't typically need to have DQs in here in your sequence, but the odd time whenever we are using a light, for argument's sake, as a step, and the fact that the light has come on is going to be used as a validation to move on to the next step. We don't have an input to say that the light has come on. There is no photoelectric sensor that we're using to say yes, that coil has illuminated. So what we do, where we need to turn on a light, the validation for that light being turned on is checking the output to validate that yes, it actually has been turned on. That's where the DQ comes in. So within the counters, within the sequence function, what I'm going to code up here in the very top is all my timers. The timers for this. So again, this is just the way I do it. All right, it works for me. We've had good results out of it, so consider it. Let's code the timers up the top. And the beauty about this is that we're going to write code here and we're never going to have to touch this again. All right, we don't come in and we don't filter with this region, no matter what the sequence or what the task dictates. So we're going to code sequence timers, So which timers do you want to code? Well, I want to code my sequence timers. They're all in sequence data, UDT sequence, right? And there they are, timers. I have timer 1 down through timer 8. Now, I'm not likely to code all the timers in this just for time wise, but it'll be a copy and paste exercise after this. So I'll show you how to do this. So the first thing I'm going to do is I'm going to go to sequence timers timer 1, right? And it is the function, right, that I want to code in this. So it's not just timer 1 in broadly speaking, it is the function, which is an IEC timer. Now I'm going to put a .t on just to specify it as an on delay timer, and look there, there's four variables or 4 inputs to that function. They're not all inputs. The elapsed time isn't an input, it's an output. It's something we can read out of it. The in is an input and says when do we start the timer. The PT is an input, how long do you want to return or run the timer for, what's the dwell, and Q is another output which goes true whenever the preset time has elapsed. When ET equals PT, Q goes high. So first thing I'm going to do in this is I'm going to program the in. Right, so T on, open up a bracket to code a function, same as any other function or specify variables. The in variable here, I want to turn this timer on whenever my step equals the timer step. So whenever sequence data dot wstep equals sequence data dot timers dot timer 1 dot w timer step, that's my input. So whenever my sequence data equals my timer 1 w step, I want that timer to come on, comma. Now I want to code in the next thing on this. My time, preset time, how long do you want this to run? Well, I want that to run for the same that I've run in sequence data dot timers dot timer 1 dot function dot pt, close bracket, and that's the timer coded. Okay, now call this timer 1. Let's Control C and let's paste this again. So in this one here, I believe we have 4 changes to make. There's 1, timer 2, 3, and 4. 4 changes to make. There's timer 2 coded. Control C, timer 3. Let's do 4 of them. There's 1 change, that 2 went to the 3. There's the second one, 2 goes to 3. There's the third one, 2 goes to a 3, and there's the fourth one, 2 goes to a 3. Let's do this one. There's the first change, 2 goes to the 4. I'm on timer 4 now. Second one, 2 to the 4. Third one, 2 to the 4. And fourth one, 2 to the 4. There's 4 timers completely coded. Just like that. Now, you wonder, how does that show that they're coded? Well, the only thing I need to do is specify when it goes on and what the preset time is. All right, so if I was to just, for the sake of showing this, I'm going to come back onto the main OB, main sweep. Network 4, I'm going to call sequence 1, and I'm going to drop my sequence 1 block onto this. Now, I'm going to map these, as I do with every one. Right? Sequence data management DI and DQ, these are indeed what I put in my parameters, my function parameters, or my PLC code variables up here. Sequence data management DIDQ, sequence data management DIDQ. These all get mapped to the my data block dot sequence 1. This is for sequence 1. I want the data that's in here to go to the sequence 1 shelf. This one here, there's only management only exists on one shelf. That's in my data dot management, and this is my data data.di, and this is my data.dq. So when I talk about my sequence data here, and I say that I want my timer to come on, whenever the step I'm in equals sequence data, or sequence data, timers, timer 1 W step, sequence data. So sequence data gets mapped to my data sequence 1. So if I look at my data sequence 1 here, there's my data sequence 1, timers, timer 1, W step. So if I want this timer to come on when I read through my problem, my task, and I see here, oh, the first timer comes on at step 30. I'm going to write 30 into my block, into my management, into the my data block. So there's 30. And what this code is doing, I'm not coding it here to run on 30. I'm asking this to keep checking the my data block, that when my current step is equal to that integer that's in that location, which I just wrote 30 in. When my step is equal to that, so in fact, when my step is equal to 30, turn on. And I want you to run for the that value, that PT that is in this location, sequence data timers timer 1 function PT, which is in sequence 1 timers timer 1 function dot PT, run for 2 seconds. Okay, so when I see my sequence, right, I'm not going to change the code in the function. I'm going to come to the my data block, and I'm going to put in the correct step in here, and I'm going to put in the correct PT in there. So at the minute there's nothing there, right? Timer 1, timer 2, right? I don't know, could be anything. You could put in 10 if you want, doesn't matter, I just leave that blank. But in a lot of cases we have 2-second dwells. A lot of cases you have 1-second dwells as well. I just left in 2 just for speed, because I know if I see 2 seconds in the dwell, I'm not even gonna flick into the function, because I know I have 2 seconds in there. But what I've effectively done now is I've coded up 4 timers, and of course you could do 5, 6, 7, 8 if you want, but I'm just going to leave it at that. Hopefully you can see the trend. So the next thing I'm going to do is I'm going to do my counters. This is a wee bit more involved. So code sequence timers, and this is going to be code sequence counters. Code sequence counters. Right. So the sequence counters come in counter 1. They come in 2 sections. I need to code the function, and I also need to code what I call the decision. So if I was just to add a page onto here, counters in sequence blocks, right? If you look at how the code works, what we're going to always have is an execute command, and then we're going to validate. Execute, validate. And we'll have this sort of a procedure all the time, right? You execute, you validate, execute, you validate, execute, you validate, which means you don't do 2 executions until you do a validation. So imagine, right? So let's just say imagine. So this is completely arbitrary, right? I have similar, let's say I'm going to hit start. Let's just go start the evaluation. Start. So execute. So let's go for extend cell A. I'll tell you what I'm actually going to do. Before I do that, imagine I have a sequence. For instance, I do A plus, and then I do say B plus C plus C minus B minus, and I want to do that 4 times, and then I do A minus. Imagine that's my sequence. So there's a counter sequence in there, right? What I'm going to do, number 1, step 1, is allocate steps. So I'm going to go for 10, A plus. So I always go up in 10s because it gives us a little bit of scope there to fit something else in. Maybe I want to get a D plus in there, right? So if I'm going to call this whole entire thing 20. Right? So this is my next step, is 20, and this is going to be 30. So the idea in this one here, the way I do it, is that my sequence shows I have an A plus, then I have a counter, and then A minus, which corresponds there to my 10, 20, 30. And so 20 is the counter, 20 is the function to do this. So I have a subroutine to run in this counter. I have a B plus, C minus, B minus. And what I do on that subroutine then is that I'm going to run that as a 21, 22, 23, 24 subroutine. Step 1 is to allocate the steps. Step 2 is draw kind of our algorithm or flowchart. So you wouldn't be doing this in War Skills, but it's just that we kind of, for this perspective, we know what's going to happen. So we're going to start evaluation. Right? First thing it's going to do, we're going to extend cylinder A. Well, you'll have your checks. Is cylinder A retracted? So let's just do that. So I'm going to say, do I have A minus question mark? If the answer, let me see if I can straighten that up a wee bit. A minus, I'm going to ask, do I have A minus? Is A back? If the answer is no, then the command is to wait. If the answer is yes, then the command is extend A. A plus. So that's the execute. Now I need to validate that. I have to ask, is A extended? Is A plus? If the answer is no, then the instruction is to wait. If the answer is yes, I proceed on to step 20. Right? So what I'm going to do is actually change, instead of that, I'm going to write it like this. I'm going to say, go to step 10. And in 10, A extends. Has A extended? Yes. If A is extended, absolutely. You go to step 20. Should have wrote that in pink. I'm just going to change that for sake of consistency. Go to step 20. That's the instruction there. Now, when I'm in step 20, I'm at my counter. Now, I'm going to ask myself, in step 20, here step 10 was A extends, and I say, is A extended? Is A what I had to do in step 10 finished? Well, what do I have to do in step 20 that I have to ask myself here, is it finished? I have to ask myself, is the counter complete? Count complete. Right? If the count is not complete, right? If that's going to be a no, right? If it's a no, if the count is not complete, what I'm going to do is I'm going to go to step 21. Right? If the count is not, if I'm at 20 and the count is not complete, then I'm going to go to 21. It's going to give me B plus. Right? And then naturally, I'm going to 21 gives me a B plus. I asked, do I get B plus? Question mark. Right? If it is a no, I'll move this road. The instruction is to wait. If it's a yes, the instruction is to go to step 22. I get a C+. It should be written in purple, maybe. So I get C+. Question mark, did you get a C+ there? Right, let's move this over. If the answer is no, the instruction is to wait. If the answer is yes, if the answer is yes, then I move on to step 23. I should go to this one here. Go to step 23. These should be in purple. So again, I'm sorry, but let's keep these right if I can. Go to step 21. Go to step 22. Go to step 23. And then in step 23, I ask myself, when I'm in 23, I'm there sitting and waiting, C minus. Have I got a C minus? Right? If the answer is no, now you got it, I need to wait. However, if the answer is yes, the next instruction is to go to step 24. Step 24. Step 24, I get B minus. So did you get B minus? Question mark. If the answer is no, the instruction is to wait. But if the answer is yes, go back to step 20. Then I go to step 20. I say, is my count complete? Well, no. If it's not complete, then go to step 21. B plus, go to step 22. C plus, step 23. C minus, step 24. B minus, go back to 20. Have you completed it yet? No, I've only done it twice. Okay, how many times do I have to? I have to do it 4 times. All right. 21, 22, 23, 24, 20. Have you completed it? No, you've only done it 3 times. All right, okay. So if my answer is no, go to 21, 22, 23, 24, back to step 20. Is the count complete? This time it is complete. I've done it 4 times. So that's a yes. Then go to step 30. Go on past 20, move on to 30. Check have I got A minus. If the answer is no, instruction is to wait. The answer is yes. Move to say seek is complete. Finish evaluation. That's it. So this loop in here, that's the subroutine that's being run on my counter. That's being looped 4 times. This here breaks me in and out of it, asking is the counter complete. When the counter is complete, the Q in the function will go true. If it's not true, it means the counter is not complete. Effectively, if the Q is true, it means I have hit my current count value is equal to or greater than or equal to my preset value. So counter 1, this is how we do it. First thing we're going to do is we're going to code the function. Counter 1, so let's do it this way, counter 1 function. The counter 1 function is in sequence data dot counters dot counter 1 dot function dot. Now, there's all the variables. If I put in CTU, right, and I open up a bracket, it's filtered it down to the ones that are applicable here. So the only ones that I need a code in here are the inputs, which is the CU, you can see it there, the PV, and the R. All right. So the CU here is going to be equal to a specific input and an increment step. So I want both an increment step and I also want an input. So whenever my sequence data.wstep is equal to sequence data.counters.counter1 dot increment step, wstep increment, and I also get some input, right? So it's going to be di dot some input in here, LOA, LOB, depends on what you're counting. Now, what is it? Which one do you use? You always use the last one. So my increment step here would be 24, and my input to validate that 24 is completed will be LOB. Right? So I'm just keeping this here as general as possible. Right? So what I'm going to do is just put in a DI dot. I'm going to put this in as one of the spares for now. See, spare 1. Right? That's it. There's CU. That's one thing I need to count. Now our code. The next thing I want to code is my reset value. The reset value in this is going to be whenever my sequence data step or my sequence data dot w step is equal to the sequence data dot counters dot counter 1 dot step reset, or sequence data dot w step is equal to 0. So I just use 0 to reset it as well. One of the two of them. And then the last thing that I want to write in this is obviously my value, my preset value. PV is equal to sequence data dot counters dot counter 1 dot function dot preset value, close bracket, and semicolon. So that's the function coded for counter 1. Now the next thing is the decision. Right, so there's counter 1 function. Let me just take the space out of that. Now I'm going to say counter 1 decision. Counter 1 branch or decision. This is an if statement. So if your sequence data, if my step sequence data dot w step is equal to the decision step, so if sequence data w step is equal to sequence data dot counters dot counter 1 dot w check step, your decision step, check is it done or not. So if sequence data is equal to that, right, and not and the counter is not complete, which you'll know that by sequence data dot counters dot counter 1 dot function dot function dot QU, then your sequence data dot W step is going to be equal to the current step, sequence data the W step plus 1. So it means go on into the counter. Else if you're going to have this again, else the sequence data is equal to your check step and you do have it complete, then your sequence step is going to be equal to what it is now plus 10. You go past it. So for argument's sake, if your check step was 20, so if my current step, my sequence step is equal to the check step, so if my current step is equal to 20 and the counter is not complete, then move my current step to what it is now, which is 20 plus 1. So move it to 21. Or else, if my current step is equal to 20, check step, and if the sequence is complete, then my new step should be equal to the current step, 20 plus 10, which is 30. And that's what you would see here. So if I'm in 20 and I'm not complete, you go to 20 plus 1 is 21. However, if I'm in 20 and I am complete, I go to 20 plus 10, which is 30. And that's that done. So that's your sequence counters completed. And then end if. Apologies. And if. Right. Now, I'm going to copy that. I'll do 4 of them. Right, so I have 10 changes to make here. It's usually 5 and 5. There's 1, counter 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's it. There's counter 2 function and decision. Control C. Counter 3. 10 changes. 1, 2, 3, 4, 5. Counters counter 3. Apologies. 6, 7, 8, 9, and 10. Done. Control C. Let's get to 3, and of course counter 4. 10 changes. 1, 2, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 4 counters. So the timers you do not have to change, right? The timers you just leave, you just put in the values in the My Data block. The counters you put in the values in the My Data block for your reset step, your increment step, and your check step, right? And then if you have to obviously update your preset values and that. But what you also must do in here though is you must update what your incrementing input is, and that's it. Right? You just update that incrementing input. There will be a case there as well where if, for instance, the sequence finishes with a counter, you say that if I'm in the check step and the counter is complete, I don't move on to plus 10. What I do is I finish off my evaluation. So there's the count timers and the counters done. So now what we'll do is we'll write in another region. No real need to put this into the region. We can just leave this out. This is going to be an if statement. And this is going to be my sequence progression. Okay, so in my initial check, I'm going to make sure that all my initial conditions are in place, and very importantly that my sequence is not complete. So it's very important there that we have a couple of our initial conditions placed in here. Now we do not put our start buttons or buttons to move from step 0 to step 10 in the sequence itself. That gets put into another block, which we'll do in the next video, which is the management block. So for argument's sake, what I'm going to do is I'm going to take my initial checks. So I'll say that if I'm in step 0 at the minute, so if sequence data dot w step is equal to 0, and sequence data, and let's do this, and not sequence data dot x complete. And right, I'll also want to check that my cylinders are retracted and everything's in the right place. So say I'll put these in that A and B are back, and di dot LOA and di dot LOB, put on LOC if I wanted to, then sequence data dot w step is equal to sequence data dot w, no, apologies, I have to set that equal to sequence data dot w step plus 10. Right, so I'm into 0. This is going to move me on to 10. Right, else if, and then I move on. So it's just going to, if equal to 10 and something else, I'm just going to keep it in as LOB, then I'll move on to 20. Control C. Let's put in a timer in here. So if I'm equal to 20, which is just going to move me on to 20. If you want, you can put in 10. You don't have to increment them up. So maybe if you look back at this, you might keep thinking you're in 10. Let's just do it that way. Let's just set it equal. Let's put in absolute values as opposed to relevant values. So if I'm equal to 10. So if I'm equal to 10 and B is back, then I'm equal to 20. If I'm equal to 20 and, now, instead of going first, checking a input, let's check to see if that a timer is complete. And sequence data dot timers dot timer one dot function dot q. So if the timer is completed, then go on to 30. Okay. Else if I'm equal to 30. Else if I'm equal to 30. And now let's just go back. Let's try a else if I'm equal to 10, and let's make that L1B, so B1 out. Let's make this that A goes out, and di dot x L1A, then go on into 40. That's it. All right. And so on, so on, and so on. Now, how does the counters come into this? Well, if the counter check step was 40, I would now be in the counter check step, and this one of these here would start evaluating. I would say, oh, my step is equal to the counter check step. I'm equal to 40. It would check to see if the counter was done. So it would either move me into 41 or it would move me into 50. So depending there on what the counter has done, what the decision is, whether to move into the counter or not, we would move here into 41 or onto 50, if indeed 40 was the counter check step. All right, so there's L1A, so there's LOA, B1 out, we started the timer, A1 out, we're going on to 40. So let's just bring A and B back and finish evaluation. So else if I'm equal to 40, and I get LOA and LOB, for instance, dot X LOB, then when I'm on my last one, what I'm going to do is sequence data dot X sequence complete. That is true. And then end if. That's it. And that's the start of your template. So there's no case statements. I don't use the case statements on the outputs. I don't use them on the inputs. I don't mix them together. Yes, it's a wee bit longer. You could write all your sequences and your outputs in the one function, but it's not quicker if you're used to, if you know how to navigate this and you have a structure in place. So that's the sequences in. That's one sequence. Now, that's sequence one. Everything's mapped. The thing about it is we can now create a sequence 2 and a sequence 3. There's nothing specific to sequence 1 in this because everything is being referenced to sequence data. Let's see that there, sequence data, sequence data, sequence data. So I can now create a sequence 2 which refers to sequence data. And sequence data then will get mapped to where you want it to go. Right? So for argument's sake, what I can do here, I have sequence 1, I can Control C, Control V. I can hit that, I can F2 it and call that sequence TWO. Right? I could drag sequence 2 down onto this, like so, and populate it. Or what I can do is I can just copy this network. Let's get Control C, Control V. There it is there. Make this one sequence 2. Why did I do that and delete the other one? It's just so I don't have to rewrite all this. It's already populated for me. What I can do is now change that one to sequence 2 and it will see it there. There it is. And this, and it map all the sequence data out of this function. Don't put that to my data sequence 1, put that to my data sequence 2. Stores it somewhere else. Now we can run into that. Let's compile. And when I compile, that'll update that call to FC5, function call 5. No errors, no warnings. And there's two sequences. Just again, the very bones. There's nothing much in them, and there never will be until we use a specific example to start populating them. So we'll get into that in not the next video, but the video after, because the next video, what I want to do is I want to focus in on the management block, which is the kind of the governance, the overall controller. You know, it keeps an eye on everything and makes all the decisions, just decides what to pull on and when to pull it on. Now the one thing I'm going to do before we finish this up is in the same vein as where we have put in conditions to move into some of these functions. I'm going to put in the same sort of conditions here for sequence 1. I do not want to scan this block at all unless I'm running sequence 1, and particularly maybe that I'm in a run mode, but I'll discuss modes again at another time. So let's do a comparator operation. Let's put in a comparator into this as well. And what I'm going to say here, I only want to run this here if my data dot management dot run sequence equals 1. Then you can access sequence 1. But if it's not equal to sequence 1, do not access that. And then sequence 2 obviously is going to be into sequence 2. Now you can put in other conditions. If I'm unsafe, maybe I want to stop scanning that as well. But for the most part, this is the way I want to run it. I don't want this checking LOA and LOB values, input values, whenever I'm not executing the sequence. All right. So this gives us a little bit of flexibility. We can take it away, we can add it in, we can add in other conditions, and it really will be from circuit requirement to circuit requirement how we control our access till the function. So yeah, again, thanks very much for coming on in. It has been a while from video to video, but I hope you've picked this one up. If you have been watching through videos 1 to 3 on this PLC series, if you do hit the subscribe, which I would ask you to do, is subscribe to that as soon as a new video becomes available on this, which I'm hoping will be in the next couple of days. You will get a notification for that. So make sure you click on to get the notifications, and certainly subscribe to it. And you'll stay in touch. Now, if you have any suggestions, you have any questions, you want me to go over anything in any more detail, drop a comment in, and I'll be more than happy to oblige and run through anything. But as I said, this is continually developing. Maybe there could be areas you're seeing how things are or not tying in, that will become clearer, through the next video or two. But certainly, if you can't wait that long, get the message into me, hit the subscribe, and yeah, we'll keep making this content and keep developing these solutions. So thanks very much for staying tuned in, and I'll see you in the next video.